and we are from Group 7.
Hello to Dr. Yanyan, and for those who are watching this video, my name is Siti Nur Shohada and I am going to represent Group 7 to present our mini project. So the project is for subject Applied Thermodynamics, and it is to achieve the course outcome 2, which is to acquire the ability to analyze and solve engineering problems that are related to heat engine cycle. Next, I am going to explain to you the prototype for our project. So since this assignment is related to heat engine cycle, my friends and I have decided to do the steam engine. And this is the outcome. I hope you can see clearly. I am going to explain each box. So the first one is the fan, and we attach it to our prototype as an output for the whole project. And next is the balloon. As you can see here, we attach the purple balloon and it works as a piston. And as you can see here, it's a bottle cap actually, and this is actually act as a piston pedal, and it the function is to initiate the movement of the piston like that. If you spin it, then it will move the piston back and forth on the cylinder here. So after that, here is the water inlet. As you can see, there is actually a hole to put the water in, and in the can or tank. And lastly, the prototype. This is the prototype's combustion chamber as a place for heat supply. So this is how our steam engine works. First, the steam engine was placed on a stable surface and it was positioned to allow the fan and piston movements to be easily observed and recorded. Secondly, the heat source was set up underneath the tank. Then the tank was heated. As the water started to boil, the water inside the tank was started to boil, it produced steam. Next, going into the essential part of this presentation is the calculations. So for the initial mass, we divided it into two parts, which is the experimental and also theoretical. So this is to find the initial mass of the water. As you can see here, we are using the formula mass equals density times volume. Next is the calculation for final mass. So as you can see here, we are still using the previous equation. Mass is equals to density and also volume. So after we obtain the result for initial and final mass, we calculate the change of mass. So we subtract the final mass from the initial mass. So for the heat supply, we are going to use the equation Qn equals to change of mass times latent heat of water vaporization divided by time. So the latent heat of water vaporization is 2260 joule. So we just plug it inside the equation together with the change of mass that we obtained earlier. For the work done, we are using the formula of work equals to pressure times volume and times change of temperature. So for the pressure, we are using the formula of rho times g, which is the gravitational acceleration, times the height. And then after we obtain the pressure, we plug it inside the equation of work done. After we manage to calculate the heat supply, we continue our calculations to find the steam engine's efficiency by using the formula of efficiency equals to work per Qn. With all being said, I am going to conclude this video presentation. So what have we learned actually from this project? So first we learned to build a steam engine by using the used goods like those empty cans, ice cream sticks, the balloons, which provide us opportunity for hands-on experience in prototyping and also testing. We had design, troubleshooting issues that we encountered, and conducted few experiments just to optimize our prototype performance. And this practical experience really enhanced our understanding and our critical thinking of the engineering design process. Secondly, designing and also fabricating a steam engine prototype is not very easy, and it really enhanced our teamwork. And also there is effective communication skills that happened in between our team. And last but not least, we learned that taking precautions are essential to prevent harm, since we are dealing with flames and all those sharp tools to build our engine. So safety is really a priority that we must look into. That's all, and thank you, Doctor.